आज हम जो है फोर्स डायग्राम या फ्री बॉल डायग्राम, इस दो ब्लॉक्स हैं उनको हम सॉल्व करने की कोशिश करेंगे। नाउ वी हैव टू ब्लॉक्स इंस्टेड ऑफ वन ब्लॉक। जो हमने लास्ट क्लास में किया था, लास्ट सेशन में किया था, उसमें सिंगल ब्लॉक लिया था और हमने देखा था उसके ऊपर फोर्सेस कैसे कैसे लग रही हैं और फ्री डायग्राम यूज करते हुए फिर हमने एक्सेलरेशन या उसके ऊपर नेट फोर्स निकालने की हमने कोशिश की। राइट, आज जो है, आज हमारे पास एक ब्लॉक की जगह पे दो ब्लॉक हैं और हम देखते हैं फिर अगर दो ब्लॉक हैं तो हम उन क्वेश्चन को कैसे सॉल्व कर सकते हैं। तो हमारा फ्री बॉल डायग्राम और फोर्स डायग्राम जैसे हमने लास्ट क्लास में किया, ये मोर लेस डिवाइड एंड रूल टेक्निक है जो कि हम लाइफ में बेसिक एस्पेक्ट्स में यूज करते हैं। किसी बड़ी प्रॉब्लम को छोटी छोटी प्रॉब्लम से छोटे छोटे पार्ट्स में ब्रेक कर लिया जाता है और फिर वहां से हम उनका सॉल्यूशन निकालने की कोशिश करते हैं छोटे छोटे पार्ट्स का, फिर उनको मिला के एक फाइनल सॉल्यूशन को हम प्रेजेंट कर देते हैं और हमारी बड़ी प्रॉब्लम सॉल्व हो जाती है। अच्छा, इसमें कुछ बेसिक स्टेप्स थे, अगर हम एक बार रिवाइज करें कि हमने बेसिक स्टेप्स क्या क्या किए थे फोर्स डायग्राम या फ्री बॉल डायग्राम में। तो जो पहला स्टेप था, इट इज आइसोलेट द बॉडी। जो ब्लॉक्स हैं, बॉडीज हैं, उनको अलग अलग कर लो, सब बॉडीज उनको अलग अलग कर लो। अलग अलग करने का मतलब ये नहीं है कि आपने उनसे कॉन्टैक्ट ही छोड़ दिया। इट इज डायग्रामेटिकली उन सबको अलग अलग बना लो। कॉन्टैक्ट अभी भी है, फिजिकल कॉन्टैक्ट अभी भी है, लेकिन डायग्रामेटिकली उनको एक दूसरे से अलग कर लो। राइट, इट इज नॉट फिजिकली यू आर सेपरेटिंग इट, you are only diagrammatically so that you can draw the forces which are acting on each block। ठीक है, तो पहला जो स्टेप है वो है सब ब्लॉक्स को, बॉडीज को जो भी हैं आपकी, उनको अलग अलग कर दो, आइसोलेट द बॉडी। सेकेंड इज ड्रॉ फोर्सेस। एक ब्लॉक की या एक बॉडी की लाइफ में जो भी फोर्सेस वो एक्सपीरियंस कर रही है, प्लीज अंडरस्टैंड, जो एक्सपीरियंस कर रही है, जो लगा रही है वो नहीं। फ्री बॉल डायग्राम में अगर एक बॉडी का आपने फोर्स डायग्राम बनाना है या फ्री बॉल डायग्राम बनाना है तो उस बॉडी के ऊपर वो फोर्सेस शो की जाएंगी जो वो एक्सपीरियंस करेगी, ना कि वो लगाएगी। ठीक है, लाइक इफ दिस इज माय हैंड, दिस इज वन फिस्ट, दिस इज सेकंड फिस्ट, व्हेन आई पुश इट लाइक दिस, सो इफ यू सी दिस कर्व इट गोज इनसाइड। तो इसका जो फोर्स डायग्राम बनेगा उसमें ये फोर्स इस तरफ शो की जाएगी, इस तरफ फोर्स नहीं शो की जाएगी। और अगर इस फिस्ट को देखोगे तो ये कर्व अंदर की तरफ है, अंदर की तरफ कब जाएगा, जब फोर्स इधर लगेगी। तो इसके ऊपर फोर्स इधर शो की जाएगी और इसके ऊपर फोर्स इधर शो की जाएगी। ये गलती नहीं करनी है कि इसके ऊपर फोर्स इस तरफ शो कर दी और इसके ऊपर फोर्स इस तरफ शो कर दी। और वेरी इंपॉर्टेंट पॉइंट फोर्स डायग्राम या फ्री बॉडी डायग्राम में, कि बॉडी जो फोर्सेज एक्सपीरियंस करती है उनको शो किया जाता है फोर्स डायग्राम में। तो अभी तक हमारे तीन स्टेप्स हैं। फर्स्ट इज आइसोलेट द बॉडी, सेकंड इज ड्रॉ फोर्सेस एंड थर्ड इज न्यूटन का सेकंड लॉ, दैट इज एफ इक्वल टू एम में, जो कि डिराइव्ड फॉर्म है एफ इक्वल टू डी बाई डी की, जो हमने बोला था उसको एफ इक्वल टू डी बाई डी या एफ इक्वल टू एम में वो देख लो, जो भी जैसे लग सकता है उसको वैसे लगा दो। तो हमारे पास प्राइमरली थ्री स्टेप्स है। पहला जो है, इफ यू वांट आई कैन राइट इट डाउन। फर्स्ट इज आइसोलेट द बॉडी, second is draw forces, third is F is equal to M में, क्योंकि जनरली अभी हम ब्लॉक्स के क्वेश्चन कर रहे हैं तो हमारे पास F is equal to M में से हमारा काम चल जाएगा। अगर ये वेरिएबल मास होता तो F is equal to dp by dt कर लेते। तो अभी क्योंकि हमारा फिक्स मास है तो dp by dt में, जैसे हमने लास्ट टाइम भी कहा, F is equal to dp by dt है, तो P जो होता है, आई थिंक इट इज विजिबल, D mv बाई dt होता है, और अगर इसे डिफ्रेंशिएट करेंगे तो ये हो गया m dv बाई dt प्लस v dm बाई dt आ गया, इज अ वेक्टर क्वांटिटी, v इज प्लस। अगर dm बाई dt दैट इज मास कांस्टेंट है तो ये जीरो हो गया। सो ओवर हियर यू गेट f इज इक्वल टू m, dv बाई dt इज व्हाट, एक्सेलरेशन, दैट इज एक्सेलरेशन वेक्टर आ गया, तो f इज इक्वल टू m में आ गया। तो अभी जो है जब हम इसको क्वेश्चंस को करेंगे तो हमारा एफ इक्वल टू एम में से, जहाँ पे फिक्स्ड ब्लॉक्स हैं, पुलिस हैं, जिसमें हमें फोर्स डायग्राम बनाना पड़ता है, तो हमारे इससे वी कैन डू ओवर विद एफ इक्वल टू एम। राइट, तो हमारे पास तीन बेसिक स्टेप्स हैं। फर्स्ट इज आइसोलेट द बॉडी, रिमेंबर द स्टेप्स, दे आर वेरी सिंपल स्टेप्स। आइसोलेट द बॉडी, सेकंड इज ड्रॉ फोर्सेस, देन थर्ड इज इक्वल टू एफ इक्वल टू एम, एंड योर क्वेश्चन इज डन। राइट, Now let's see if we have a two block system. अगर अब हमारे पास दो ब्लॉक है, अच्छा अब दो ब्लॉक कैसे हो सकते हैं? दो ब्लॉक जो हैं ज्यादातर देयर टू ब्लॉक्स जो हमारे पास क्वेश्चंस आ सकते हैं वो आ सकते हैं लेट्स से एक के ऊपर एक ब्लॉक रखा हुआ है, एक के साथ में एक रखा हुआ है, या ऐसे भी किया हुआ है लेट्स से एक के साथ में एक स्ट्रिंग के साथ अटैच्ड है, दिस इज स्ट्रिंग के साथ में अटैच है, दे आर नॉट इन डायरेक्ट कॉन्टेक्ट, दिस इज इन डायरेक्ट कॉन्टेक्ट। यहाँ पे जो है स्ट्रिंग के साथ अटैच्ड है और यहाँ से हम कोई फोर्स लगा रहे हैं, हमें पूछा जाता है व्हाट इज द टेंशन एटसेट्रा इन द स्ट्रिंग, वी आर आस्क्ड व्हाट इज द टेंशन एटसेट्रा, राइट? So when the blocks they are in contact, this direct contact, then remember we can have only pushes only, that is one block can only push the other block. If we don't talk about कि इसके ऊपर कुछ चार्जेस हैं, इसके ऊपर पॉजिटिव चार्ज या कुछ नेगेटिव चार्ज है, उस तरह की बातें नहीं कर रहे हैं और हम डायरेक्टली कह रहे हैं लेट्स से हम इसमें बात कर रहे हैं दे आर इन डायरेक्ट कॉन्टेक्ट विद ईच अदर, तो एक दूसरे को सिर्फ पुश कर सकते हैं। अगर थ्रेड से कनेक्टेड है तो थ्रेड के थ्रू ये एक दूसरे को पुश नहीं कर सकते, ये सिर्फ से पुल कर सकते हैं, स्ट्रिंग में टेंशन आएगा। If I take this as a rod, in this rod I can have both the things, I can have a compression also and tension also. If I pull it, then this is under tension. If I compress it, then it is under compression, right? Later on your engineering, let's say if you go for engineering, you'll find that is even in one beam when it bends you can have a compression and tension, tensile forces in the same beam also, right? But right now अभी हमारे पास जो है, जब हम क्वेश्चन अभी एलिमेंट्री लेवल पे डील करेंगे तो हमारे पास अगर स्ट्रिंग है, स्ट्रिंग में टेंशन ही हो सकता है। स्ट्रिंग के थ्रू ये नहीं हम कर सकते कि हमने इसको यहाँ से पुश किया और उसकी वजह से ये आगे पुश हो गया, दिस इज नॉट पॉसिबल, राइट? अगर ये रॉड होती तो कर सकते थे। और इसमें जो है these two blocks in they are in direct contact with each other, so they can always they can push only each other. Let's see, इसका फोर्स डायग्राम बनाते हैं। Let's I say this is for convenience purpose, this is 5 kg body, this is 10 kg body. तो पहला हमारा स्टेप है कि इन दोनों ब्लॉक्स को अलग अलग कर लो, फिजिकली अलग करना है, डायग्रामेटिकली अलग करना है। तो ये आ गया 5 kg आ गया एंड दिस इज 10 kg. Your first step is done. First step is isolate the body. Isolate the body. Second is draw forces. Third is you go for F is equal to ma, where F is the resultant force. This is the resultant force, remember it. Now 5 kg, 10 kg, this is a table. Second is draw forces. I have to draw the forces. Whenever you draw the forces, first is you can start with the earth. That is what the forces the earth is going to apply in the blocks. So this is going to block is going to experience a downward pull by earth. Earth has a tendency to pull all the objects towards the center. To pull all the objects towards the center, and it is pulling with the force mg, mass into g is accelerated due to gravity. And if we take g instead of 9.81 as 10 meter per second square, so that the calculation part becomes easy and we can spend more time on the concept rather than getting involved in the elementary basic calculations. So I take over here that earth is applying a force of mg, that is 50 Newton. Do not say that is 5 kg weight. This is a layman's language. In day-to-day language, you can say that is my weight is 70 kg, 80 kg, 50 kg or so, but not in physics class. You cannot say that because kg is a unit of mass, and over here we are talking about weight. Weight is a force. Force is a vector quantity, mass is a scalar quantity. So if someone asks what is the weight like, so 5 into g, 50 Newton, and this is m into g, 10 into 10, 100 Newton. So now earth, the forces which earth is going to apply, that job is over. Now I start from the top and towards the bottom. 5 kg block is going to apply a force on 10 kg in the downward direction. So this will experience a force, say F1 in the downward direction. Please do not be in a hurry to say, sir, this is F1 is equal to 50 Newton. Now when this is stationary, it may be in this case, but when the cases they are going to complex or the acceleration they are going to be there, you cannot directly jump to the value. You will have to solve it. So let's use the basic method, and we are not much bothered about what is the result like. We are bothered about, let's say, what is the concept like, how to apply it, and the answer more or less will come by itself, right? So this is going to apply a force F1 in this direction. If this is going to push it down, then this will also retort back. ये भी बोलेगा तुमने मेरे को नीचे दबाया है, मैं भी तुम्हारे ऊपर फोर्स ऊपर की तरफ लगाऊंगा, because to every action there is equal and opposite reaction. Newton's third law. When you remember Newton's third law, do not remember only that is that to every action there is equal and opposite reaction. There is second line also, which is very, very important once you are going to do the numericals or questions on, let's say, laws of motion. That is action and reaction, they are always on two different bodies. They are not on the same body. So that's why the forces, they always exist in pairs, because to every action there is equal and opposite reaction. So now, if this is going to apply a force F1 onto this, this retorts back, this applies F1 back. Now there is an interaction between these two also. So this will push the table down with a force F2. I don't know what is the value of F2 in terms of F1, 15 and 100 Newton or so. I'm not bothered. I'll just say this applies a force downward. So this will say apply a force F2 in the upward direction. See, I have these blocks and these arrows, they belong to a body. I have not drawn, let's say, midway only, so later on I get confused. Your neat and clean diagram, they facilitate the process of thinking. Clumsy diagrams, they will confuse you further. So be very clear initially at least, to lots of space and to draw very neat and clean diagrams. Each arrow is fixed to a body. This belongs to this, this belongs to this, this belongs to this. This belongs to this, this belongs to this, this belongs to this. There is no confusion. So now in its life, one is this force, one is this force. Force is like F2 is in the life of table. So now my second job is done, first is done, second is done. Right? Now I see I have to go to the, let's say, third step, that is F is equal to M. If I look at this 5 kg block, it is over here. Is it moving? So acceleration is, I know it is dV by dt. Acceleration dV by dt. What is acceleration? What do you call this acceleration? Is it an instantaneous acceleration or average acceleration? You have heard about it. You have speed, you have average speed. You have velocity, you have average velocity. You have acceleration, you have average acceleration also, right? Anyway, this will do another other session or so. Right now I simply say, otherwise we will digress from the topic. A is equal to dV by acceleration is rate of change of velocity. So this block is stationary and it remains stationary. Do not say it is stationary, so that's why acceleration is equal to 0. This remains stationary. That is, there is no change of velocity. There is no change of velocity vector. Remember, that is, velocity is a vector quantity. It has a magnitude, it has a direction. If out of these two, if even a single thing changes, be it magnitude, be it direction, so velocity vector will change. So then the acceleration vector will come into being. So over here, neither the magnitude changing, obviously this remains stationary, so acceleration is equal to 0. So when acceleration is equal to 0, so it means net force has to be equal to 0. If net force onto this is equal to 0 and their forces, F1, 15 Newton. Do not confuse F with the resultant force. There are two things. One is the force, the other is resultant force. There is a difference between these two. F1 and 15 Newton, they are the forces. Resultant force is going to be a single force which produces the same result as being produced by a combination of forces. So over here, acceleration of this block is equal to 0. If acceleration is equal to 0, the net force is equal to 0. The upward forces, they have to be equal to downward forces. So F1 is equal to 15 Newton. If you wish to write Newton whole thing, it should be small n. N means WTUN. It is in the name of the scientist. If you have to write N only, then capital N, right? For this, how many forces do you see onto this? There are 3 forces. 1, 2 and 3. Do not try to make a category of these two and this is something different. All of them, they have the unit as Newton only. So what to do in this type is, let's say there are 3 forces, 1, 2, 3. How many forces downwards? This and this, that is downward, this is upwards. Acceleration is equal to 0. When acceleration is equal to 0, net force has to be equal to 0. When net force has to be equal to 0, downward forces, they have to be equal to upward forces. What are the downward forces? Downward forces, don't say that is at the lower surface. Downward forces means directly downwards. This is a downward force, this is a downward force, this is a downward force. Now we are just talking about this. Onto this and this, they are downward forces, and this is upward force. Acceleration is equal to 0. So downward forces, they have to be equal to upward forces. So F1 plus 100 is equal to F2. F1 value you can put it from here, 50. 50 plus 100, so directly I say 150 Newton is equal to F2. Be it this one, be it this one. To our reaction, there is equal and opposite reaction. So this value comes out to be 150 Newton. This is okay? So I have basic 3 steps. Isolate the body, draw forces, F is equal to ma. That's all. Now, if someone says this whole thing is accelerating up with a force, with the acceleration of suppose 1 meter per second square, now what? The force diagram remains same. So for this equation now, if this is going 1 meter per second square, accelerating up, so where is the observer? Who is seeing it? 1 meter per second square. Please, that is very important, is always be aware of where is the frame, reference frame. Where is the observer? Who is writing the equations? That is very important. Over here I say that is someone, a person on the ground. He is seeing the whole thing. He sees 1 meter per second square upwards. So if he sees 1 meter per second square upwards, and he is making the equations, right? So he sees that this block is also going up with acceleration 1 meter per second square, and this is also going up with 1 meter per second square upwards. So if this is accelerating up, and if I say F is equal to ma, in vector notation, acceleration, this is equality sign. If this is equality sign, it means this side is equal to this side, both ways, magnitude wise also and direction wise also. If acceleration vector is upwards, so it means net force also has to be upwards. So net force has to be upwards, it means this should be greater than this. They are in the opposite direction, so they have to be deducted. So this should be greater than this, then only this will accelerate up. So equation for this, F1 minus 50 Newton. What is this? This stands for FR, resultant force. There are two forces. Resultant is what? F1 minus 50. That is the resultant force. What is the mass of this body? Only consider mass of this body. Now story of this thing we are considering it. Mass is 5 into 1. So F1 is equal to 55 Newton. Do not say in these cases, that is weight changes. When you are preparing for the specially examination like medical and IIT, students, they tend to say that is the weight of the block. When you are in the lift, the weight increases when the lift is going up and it decreases when it is going down. No, it is not appropriate. Weight remains same, it is the apparent weight. Apparent weight changes, and that too depends upon that is acceleration or the body is going with a constant velocity. Now what is apparent weight? Apparent weight is, suppose you are going in a lift, that is in a vertical lift, it's going up, and beneath you, you have under your feet you have a weighing balance. The reading it is going to show, that is apparent weight. Now over here, F1 minus is equal to 5 into 1. So F1 comes out to 55 Newton. For this, what is the equation like? It is also accelerating up with 1 meter per second square. So upward forces minus downward forces, that should be the net force, direction. So it is F2 minus downward, F1 plus 100. This is net force, upward forces minus downward forces. Do not consider these forces now. We are talking about this body. So onto this body, F2 is upwards, F1 is downwards, 100 is downwards. So upward forces, if you wish to intend to put bracket, that is fine. So one bracket belongs to upward forces, one bracket belongs to downward forces. You see that is which way the body is accelerating. If this is accelerating upwards, so upward forces minus downward forces. If it is accelerating down, downward forces minus upward forces, and so on. So for this, upward force F2 minus this is equal to mass. Mass is 10 into acceleration is 1. You can put the value of 55 over here, let's say over here, and you can get the value of F2, value of this, you can get it. It's okay. Now, if instead of this 1 per second square, I say this is the whole thing is going down 2 meter per second square. So now let's see what are the changes which are going to there. This is accelerating down 2 meter per second square. So this is also accelerating down with 2 meter per second square. Net force onto this, net acceleration is in which direction? It is in the downward direction. So net force has to be in the downward direction. So it means you will do downward forces minus upward forces. So equation for this 50 minus F1 net force is equal to mass 5 into acceleration is 2. You can get the value of F1. Now if you talk about this one, this is acting down. So downward forces minus upward forces. Downward forces F1 plus 100 is downward force minus F2 is equal to mass. Mass is 10 into that is 2, and you can get the answer. You can just put the values and you can get the answer. So simple.